This is Mrs. Davis. This is AP Pre-Cal. We are working on Unit 3B in the review, and we're working on starting with problem 7. So we have new directions here. The directions say find the exact value for each composite function. Okay, so let's start with the first one, number 7. And what we're going to do when we see this inverse trig function, we're going to build a triangle, and then we'll be able to take the outer non-inverse and see there's secant, cosecant. So we have to find the cosecant first, and then we can find the secant. Now, the first thing we have to do is think about what quadrant this is in, and this is cosine, okay, or sorry, it's sine, and sine is positive in quadrants 1 and 2, but inverse sine is positive only in quadrant 1, because if you remember what inverse sine domain is, it's from negative pi over 2 to pi over 2. So we're in quadrant 1, so we can draw our triangle there. Now, if you remember that cosecant is hypotenuse over opposite. So we are going to put the hypotenuse as the square root of 5, and opposite would be 2. And so then this would be the square root of 5 squared, which is 5, minus 2 squared, which is 4. So this would be 1. So this would be our theta. We'll call that theta. So then we can say that secant theta would be equal to, and now just look for hypotenuse, right, over adjacent, because that's what secant is with the 1 over the cosine. So that's it. So secant theta, would be equal to the square root of 5 over 1, or just the square root of 5. Same thing for number 8. We have an inverse tan. Now, the domain for inverse tan is from negative pi over 2 to pi over 2, and we have a negative, so that means we must be in quadrant 4. So we're in quadrant 4, and so tangent is sine over cosine, right, or opposite over adjacent. So this would be negative 3, and this would be 1, which makes this square root of 9 plus 1, or the square root of 10. So if we make this theta, then we can say that the sine of theta, which is equal to opposite over hypotenuse, is negative 3 square root of 10 over 10. Down to number 9, we have an inverse secant, and its partner is cosine, and this is a negative, and cosine, inverse cosine's domain is from 0 to pi, so this would have to be quadrant 2. Quadrant 2. So I'm going to make that theta, and now this is hypotenuse over adjacent. So this is 2 square root of 3, and this is, actually, let's rewrite this, because that's weird. It's negative 2 square root of 3 over 3, but that's the same thing as negative 2 over the square root of 3. That's a more common way we'll see that switched around, because that's negative square root of 3 over 2 flipped. So that means that this would be 2, and this would be negative square root of 3, and then this would be 4 minus 3, which is 1. And so then if I take the cotangent of theta, which is equal to the adjacent over the opposite, then I get the square root, negative square root of 3. So cotangent of theta is negative square root of 3. Number 9, I have an inverse cosine, so it's positive. That would be quadrant 1 then. So if I'm going to make that theta, then this would be adjacent over hypotenuse, so that's 15, and that's 17. And our Pythagorean triple triangle with 15 and 17 is 15, 8, 17. So this would be 8. So then if I take the tangent of that theta, that triangle I just built, the tangent is the opposite over the adjacent, so that would be 8 over 15. Right, let's go on to number 11. This time, we're to write the trig expression as an algebraic expression. So they just give us the x value here. So we're at tangent and it's positive, so we're going to be quadrant 1. And if tangent is sine over cosine, then this is x and this is 1, which means our hypotenuse must be x squared plus 1, the square root of x squared plus 1. So then if I take the sine of that, so we're doing the same thing just with that, that would be x over the square root of x squared plus 1. I don't have to worry about rationalizing that. All right, so on the same vein, if I have a cotangent, we'll put it in quadrant 1 since it's positive. We'll put theta here. Sorry. And this time cotangent is adjacent over opposite, so this would be x, and this would be 1, so this is still the square root of x squared plus 1. So then the cosecant of theta, the cosecant is 1 over the cosine, so which is equal to the hypotenuse over the adjacent, and so that's equal to the square root of x squared plus 1. Oh, sorry, cosecant goes with sine, so this is over opposite over 1. So cosecant theta is the square root of x squared plus 1. All right, and let's try to finish out this page on this video. So now we're going to solve them. But they give us this nice 0 to 2 pi, but notice it does include 2 pi and 0. So we have to decide how we're going to do this. This totally looks like it's going to be a quadratic pattern. And you solve quadratics by setting everything equal to 0. So you'd have 2 sine squared theta minus sine theta minus 1 equals 0. So then if we let a equal sine theta, we have 2a squared minus a minus 1 equals 0. And that factors to 2a, this has to be 1, this has to be 1, and we want to have two negatives and 1 positive. So that would be 2a plus 1 and a minus 1. And so put that back as 2 sine theta plus 1 equals 0, and sine theta minus 1 equals 0. So sine theta is, went too fast. Sine theta would be negative 1/2, and we're going to solve that. Sine theta is negative 1/2 all the way from 0 to 2 pi at quadrant 3 and quadrant 4. So that would be 7 pi over 6 and 11 pi over 6. You got to know your unit circle. Sine theta is 1 only at theta is pi over 2. So our solution is theta equals, let's go in order. First would be pi over 2, then 7 pi over 6, then 11 pi over 6. And now let's look at this one. Now we have a sine and we have a tangent. And we have to probably set this all equal to 0. So I think, though, first I'm going to change this to sine and cosine and see what appears. I think you'll see right away. So we have sine theta over cosine theta equals 2 sine theta. Now, you know something that starts with 2 sine theta. If you use the double angle identity, which says that that the sine of 2 theta is equal to 2 sine theta cosine theta. All right, so if we multiply this on that side, we get sine theta equals 2 sine theta cosine theta. So now let's move that and set it equal to 0. So I have sine theta minus 2 sine theta cosine theta equals 0. So factor out a sine theta, and I get 1 minus 2 cosine theta equals 0. Okay, so sine theta equals 0 at 0, pi, and also 2 pi, because remember it's included. And then we have 2 cosine theta is equal to 1, so cosine theta is a half at pi over 3, and it's also positive at 5 pi over 3. So theta would be equal to 0, pi over 3, then pi, then 5 pi over 3, and then 2 pi. All right, so there is number 7 through 14.